video, we want to look at how fast this infusion is running. We want to think about whether or not an adjustment needs to be made based on the remaining volume and remaining time. And whether or not that adjustment is needed, we want to compare that to the original value, what it's currently operating at, and whether or not it is appropriate to make that change. So there's quite a lot going on in this video. The first thing that I'd like to do is just to determine how fast this infusion is running. And so if you want to pause the video here, get a stopwatch out, count the number of drops over 15 seconds. I'm going to do the same. And I'm going to just know, because I've already done this, when I did my 15-second countdown, I saw that there were 11 drops that fell in 15 seconds. Now, if you got 10, if you got 12, I mean, it all depends, I suppose. I mean, drop or two over 15 seconds can have some variation. But I know when I counted 11 drops per 15 seconds, I'm going to use my understanding of equal ratios. Well, it's in 60 seconds. That's an increase of a factor of 4. So that means this would be 44 drops falling. If 11 drops fall in 15 seconds, then 22 fall in 30 seconds, 44 fall in 60 seconds. So this is operating at a speed of 44 drops per minute. That's how fast this is currently running. Now, according to the second problem, which we're going to flip over to the next screen, we're going to come back to this 44. But what I know is, according to what's left, there's 150 mLs remaining. I'm using tubing where there's 10 drops per ml. And I need this to finish in 1 hour and 15 minutes. That's how long I would like this to finish in. So what I need to think about is, if these are my parameters, I want to know what is the adjusted rate if I want 150 mLs to be infused in 1 hour and 15. So I know there are 150 mLs left, and each ml is going to be broken into 10 drops. So just a quick one-step dimensional analysis. I see there are still 1,500 drops remaining to be infused in this bag. Those 1,500 drops will be infused in 1 hour and 15 minutes. When I turn that into just total minutes, 60 minutes plus 15 minutes gives me 75 minutes. So I know 1,500 drops needs to infuse over 75 minutes. So I set up my rate. I simplify this to be 20 drops per minute when I find that unit rate. So right now, this is operating according to the speed here. This is operating at 44 drops per minute. In order for this to finish at the appropriate time, I would need to change it so that it's going from 44 now down to 20. The question is that appropriate? Well, according to our hospital protocol, we can make that adjustment if the percent change is less than 25%. Now, you might be thinking, why not just make the change? Well, depending on what the medication is, the patient may not be receiving the medication in a quick enough time, or maybe we need the patient to receive it over a longer period of time, which is the case here. So it all depends on the situation, and when you're talking about medication, it's really important to make sure you're not fluctuating or changing that value too drastically. So our protocol that we're going to be following is 25%. And this is a good review from things we've talked about earlier in this academic year. Absolute change and relative change. So if you think back, let's think about what the original value was, the original rate. What it's currently operating at is 44 drops per minute. What the adjusted rate would be, we calculated for this to finish on time, the adjusted rate. What we need to change this to is 20 drops per minute. So the absolute change, if I just look at these and compare what's from the original value to this new value, if I subtract those, I see this is a reduction of 24 drops per minute. So this is an absolute change. We're reducing Reduction or reducing by 24 drops per minute. That's our absolute change. I will abbreviate that AC. The absolute change from our original rate to our new rate is 24 drops per minute. The relative change, we want to consider the absolute change, so the absolute change over the original value. So this is going to be a percent. In this case, we're talking about a rate. So our absolute change, this is a reduction of 24 drops per minute. That's what we found. Relative to the original value, original rate, which was 44. And so now I'm going to get out my calculator. I'm going to turn this into a decimal and then convert this into a percent. So the decimal equivalent is 0.54 repeating. So I'm going to write that out, 0.54 repeating. And if I round this, I turn this into a percent, round it to the nearest tenth, I get this is 54.5%. So our relative change, we would be reducing the original rate by 54.5%, which is significantly more than our 25 cutoff. So that means we would not make this adjustment. That's too much of a change. We want to hold off, check with the prescriber.